Okay, so this is going to be a video of how to do a shortcut for the derivative, but when you have a function that's not just given to you in standard form like this, where everything is either pluses or minuses, or when the connection is multiplication. When it's multiplication, obviously you just do the derivative of one, keep the other one the same, and then swap and then add the results, right? This is a little bit more complicated when you've got a fraction. So this looks terrible, but I promise it's not. So if you remember, it's sort of the exact same thing we had here in the quotient rule, like keep one of the objects the same, take the derivative of the other one, then keep the first object the same and take the derivative of the other one, right? And so this is really very similar to what we just did in class earlier, or the video of me just doing this. So if you want to take a look at that video before this one, I would recommend doing that. But here's really what that means. G of x is the bottom. So this is really keep the bottom one the same, then take the derivative of the top, then do the top times the derivative of the bottom, and then square the bottom. Okay, it sounds like a lot, but let me go through it one more time. Bottom, keep it the same, derivative of the top. Then switch, keep the top one the same, take the derivative of the bottom one the same. So this is g of x, this is f of x. And I'm not really, I guess we could use that notation if we really wanted to. I'm just going to remember bottom top. Okay, so the bottom derivative is going to stay the exact same, but it's going to be squared. So to find the derivative of this entire thing, we're going to take the bottom function, keep it exactly the same, but square it. Ta-da, look, halfway done. Okay, and then I just remember bottom top derivative. Bottom. The bottom has x plus 3 in it, so I'm keeping it the same. Bottom, then the derivative of the top. The derivative of the top is 5x to the fourth plus 3x squared. And I got that by using our shortcut. Take this top number, multiply it by this number here, which is obviously a 1, 5x to the fourth because we decrease a degree. 3 comes out in front, multiplies by this 1, so 3x squared. Okay. Bottom, top derivative, then a minus sign, then we switch. So what did I keep the same? I kept the bottom the same, and I took the top derivative. So now I'm going to do that backwards, meaning I keep the top the same, and take the bottom of the derivative. The derivative of the bottom, 1x to the first, multiplies by this. X to the first becomes x to the 0, so the derivative of the bottom is just 1. So let me go through that one more time with you. Bottom keeps the same, derivative of the top. Keep the top the same, take the derivative of the bottom. Take the bottom and square it. So this bottom part stays exactly the same. Bottom, top derivative, top the same, bottom derivative, subtract it out, multiply it through. So if I FOIL the top out, and I'm not going to FOIL the bottom part out, why bother? I'm just going to leave it like this. If I FOIL this out, which I don't have to, but I'm going to, 5x to the fourth becomes 5x to the fifth, then 3x cubed, then 15x to the fourth, then 9x squared. I don't have to do any of this, but I just FOILed this out, giving me this. And then when you multiply this by 1, naturally these all stay the same, and I'm going to distribute that minus sign. So minus x to the fifth, minus x cubed, minus 22, right? Minus, minus, minus. And if I really wanted to now, I could combine my like terms and get real fancy. 5x to the fifth minus 1x to the fifth is 4x to the fifth. 3x cubed, take away an x cubed. It's minus 2x cubed, sorry, positive 2x cubed. There's only one x to the fourth term, I think, so plus 15x to the fourth. So I combined this, I combined this, I combined this. There's a 9x squared in there, so I might as well write that in there. And then the minus 22 at the back. So, see? Piece of cake, no problem. Just kidding, I know that looks super overwhelming. We'll practice that a little bit in class, but again, the idea is bottom, whatever is here, gets squared. Then keep the bottom one the same. The order is important here, so keep the bottom one the same, derivative of the top, then switch. Derivative of the top, top the same, then derivative of the bottom. So whatever you did here, it's just reversed here. Okay, hopefully that helps, and hopefully we can clarify it some more tomorrow.